Hello, so this is chapter 5 of Porth's Pathophysiology book. Chapter 5 starts off talking about cellular adaptation, and it starts on page 101. Cells adapt to change in the internal environment. So just as the total organism adapts to changes in the external environment. Cells may adapt by undergoing change in size, number, and type. These changes occur singly or in combination and may lead to atrophy, hypertrophy, hyperplasia, metaplasia, or dysplasia. This slide is just going to talk about down here in the notes section, she has the definitions of each of those listed, so I'll just read those out loud. Atrophy is a reversible reduction in the size of the cell. It results from disuse, insufficient blood flow, malnutrition, denervation, or reduced endocrine stimulation. Hypertrophy is an increase in the size of the cell due to increased workload. It can result from normal physiologic conditions or abnormal pathologic conditions. Hyperplasia is an increase in the number of cells is caused by increased workload, hormonal stimulation, or decreased tissue. An example would be uterine enlargement during pregnancy is the result of estrogen stimulation. So hyperplasia is the increase in the number of cells. Metaplasia is the replacement of one adult cell with another adult cell that can better endure the changes or stress. It's usually a response to chronic inflammation or irritation. And then dysplasia says, in dysplasia, deranged cell growth of specific tissue results in abnormal size, shape, and appearance. So although dysplastic cells changes are adaptive and potentially reversible, they can precede cancerous changes. So just like to recap on that, atrophy is reversible and it's a reduction in the size of the cell. Hypertrophy is an increase in the size of the cell due to increased workload. Hyperplasia is an increase in the number of cells caused by increased workload. Metaplasia is the replacement of one adult cell with another adult cell that can better endure the changes. And then dysplasia is a lot of different things going on. So an abnormal size, shape, and appearance. The next slide is causes of cell injury. It says physical injury results from a disruption in the cell or in the relationships of the intracellular organelles. Two major types of physical injury are thermal, like electrical or radiation, and mechanical, trauma or surgery. Causes of thermal injury include radiation therapy or cancer, X-rays, and ultraviolet radiation. Causes of mechanical injury include motor vehicle crashes, frostbite, and ischemia. I'm going to go back to slide number 8. Actually back to slide number 7. So cellular adaptations was on page 101, and then as you go through the atrophy and hypertrophy, hyperplasia, it just goes from page 101 to 102 to 103. So 101 to 103, you can find the information on that slide. And then here, if you go over to page 107, it'll start talking about the injury from physical agents like mechanical forces. Injury or trauma due to mechanical forces occurs as a result of body impact with another object. Extremes of temperature, of course, extremes of heat and cold can cause damage to the cell, its organelles, and its enzyme systems. Electrical injuries can affect the body through extensive tissue injury and disruption of neural and cardiac impulses. So voltage, type of current, amperage, pathway of the current, and resistance of the tissue and interval of exposure determine the effect of the electricity on the body. And there's a really radical photo of someone with his hand burned. It said the victim was electrocuted after attempting to stop a fall from a ladder by grasping a high voltage line. And that looks pretty gnarly, so we don't want that. Moving on, let's go to slide number 10. Causes of cell injury are continued here, and it just continues to go on from page 107 through page 110, and talks about chemical injury. Chemical injuries may be, I can't see this, hold on, sorry. Chemical injuries may be caused by factors inside the body called endogenous factors or outside the body called exogenous factors. Common endogenous factors include genetically determined metabolic errors, gross malformations, and hypersensitivity reactions. Exogenous factors include alcohol, lead, carbon monoxide, and drugs that alter cellular function. Examples of such drugs are chemotherapeutic agents used for cancer treatment and immunosuppressive drugs that prevent rejection in organ transplant recipients. So I guess those would be considered exogenous factors. Yeah, so chemotherapeutic agents and immunosuppressive drugs are exogenous factors that can affect or cause cell injury. Injury from biologic agents, viral, fungal, protozoan, and bacterial agents can cause cell injury or death. These organisms affect cell integrity, usually by interfering with cell synthesis, producing mutant cells. For example, a human immunodeficiency virus alters the cell when the virus is replicated in the cell's ribonucleic acid. And it goes on to say injury from nutritional imbalances also occurs, and this is when a deficit of water, oxygen, or nutrients occurs, or if constant temperature and adequate waste disposal aren't maintained. Cellular synthesis can't take place. So just like your car or anything else, really, if it doesn't have enough water and gas and oil and all of the nutrients that your car needs to continue functioning properly, then it can't do its job. So, and cells synthesize proteins and things like that to perform functions in our body. So we want to give them all of the nutrients and things that they need. It says a lack of just one of these basic requirements can cause cell disruption or death. But this information, like I said, goes all the way through page 110. And then the next slide talks about programmed cell death, apoptosis, falling apart, equated with suicide. This is found on page 113. It says in most normal non-tumor cells, the number of cells in tissues is regulated by balancing cell proliferation and cell death. Cell death occurs by necrosis, or a form of programmed cell death called apoptosis. Apoptosis is a highly selective process that eliminates injured and aged cells, thereby controlling tissue regeneration. Cells undergoing apoptosis have characteristic morphologic features as well as biochemical changes. As shown in figure 5.9, Shrinking and condensation of the nucleus and cytoplasm occur. And then it just goes on to talk more in detail about how all that happens. It says apoptosis is thought to be responsible for several normal physiological processes, including the programmed destruction of cells during embryonic development, hormone-dependent dependent involution of cells, and then death of immune cells and cell death by cytotoxic T cells. And it goes on to talk about more things like that. Here in her notes, under the slide, actually in the PowerPoint, it says in most not, okay, I think she just put in what was in the book from there. Yeah. Oh, she added one extra thing. It says it also separates the webbed fingers and toes of the developing embryo. So that's interesting because sometimes, people are born with those still intact, and maybe that means there was some sort of issue during the apoptosis process when they were in the embryonic stage of their development. So, moving on to the next slide. Programmed cell death is continued on the next slide, and it talks about necrosis, which we've all heard the word necrosis, but I thought it was interesting because there's a little difference between necrosis and apoptosis. Necrosis is located on page 114. That's where it starts at anyway. And it says necrosis refers to cell death in an organ or tissues that is still part of a living person. Often interferes with cell replacement and tissue regeneration. And gangrene is on page 115, and it says gangrene occurs when a considerable mass of tissue undergoes necrosis. But just to back up a little bit and talk a little bit more about necrosis and how it's different from apoptosis, because you think apoptosis is cell death and then necrosis is cell death, but the way it differs is that apoptosis doesn't cause, or it doesn't trigger the inflammatory process. So necrosis differs from apoptosis since it causes loss of cell membrane integrity and enzymatic breakdown of cell parts and triggers the inflammatory process. And it also says that, it says, let's see, it says, in contrast to apoptosis, which functions in removing cells so that new cells can replace them, necrosis often interferes with cell replacement and tissue regeneration. With necrotic cell death, there are marked changes in the appearance of the cytoplasmic contents and the nucleus. These changes often are not visible, even under the microscope, for hours after cell death. The dissolution of the necrotic cell or tissue can follow several paths. The cell can undergo liquefaction or liquefaction necrosis, I think is how you say that. It can be transformed to a gray, firm mass, which is called coagulation necrosis, or it can be converted into a cheesy material by infiltration of fat-like substances, and that's called caseous necrosis. And then it goes on to talk about in more detail the differentiation between those types of necrosis and how your body will react to that. Gangrene is, like I said, on page 115. The term gangrene is applied when a considerable mass of tissue undergoes necrosis. Gangrene may be classified as dry or moist. In dry gangrene, the part becomes dry and shrinks, and the skin wrinkles, and its color changes to a dark brown or black. And then it talks more about that, and then the next paragraph talks about in wet or moist gangrene, the area is cold, swollen, and pulseless, and the skin is moist, black, and under tension. Bleps form on the surface, and liquefaction occurs, and a foul odor is caused by the bacterial action. So there you go. Hope you guys enjoyed this.